Welcome to the Polymer Science Podcast. I am Dr. Alira Health.
And I'm Jacob Shackman.
In this podcast, we'll be speaking to researchers from around the world and talk to them about how their work is improving our daily lives. I hope you enjoy our conversation and that you learn something new. Hello everyone, today we're talking with Ingmar Van Hengel. He is a PhD candidate at Delft University in Biomedical Engineering. He also has a mind for business when he created his first startup company called SkinPrint for the treatment of burn wounds, using bioprinting to develop skin using the patient's cells and biocompatible natural polymer materials. He then shifted his focus to developing multifunctional 3D implants for orthopedic patients that are longer lasting and can combat bacterial infection. He has continued to grow his expertise in the digital health field and was a business analyst for PatchAI, which develops intelligent digital health engagement solutions for decentralized clinical studies. He is now working for Alira Health in gathering data and doing research that can contribute greatly to the overall health of the society. This is the first podcast interview that I'm doing now with the baby, so we'll see how it goes.
I hope everything is all right.
Yeah, no, everything is fine. I just want to know how's it going with you though, like just before we start, like how are you doing?
Doing good?
Are you like very, very busy at the moment or how?
Because I'm at the same time basically doing two things, so you might have seen that I now work for Alira Health, so that's basically a full-time job. And next to that I still have to wrap up my PhD.
Right.
Yeah.
That's always tricky, balancing those two things out.
Yeah.
How long have you been working on your PhD?
So my PhD in the Netherlands is 4 years, and then due to COVID I got 3 months extension. So then pretty much the experimental part was done. But then I just needed to write the thesis, and that takes a lot of time. Especially if you have to do it part-time.
And also having to focus on something else other than your actual thesis, it really extends that time a lot. Yeah. Now I remember those days. I kind of went like, you gain a bit of cabin fever if you don't get out and exercise and do other things than just sit and typing. Ugh.
Yeah.
Well, so you're going to continue working at is it Alira Health, you said, right?
Alira Health, yep.
Okay, you're not going to do a postdoc or continue studying in other ways? Okay.
No, I don't think so. I mean, I just realized during my PhD that although I really liked it, I also missed a little bit that my research, although it was very applied, in the end wasn't really applied for people. That was something that I missed.
See. Yeah.
And that's basically also why I got into digital health. I mean, we'd be happy to elaborate a bit on that because it doesn't seem, I think, a very logical choice if you go from, let's say, materials or biomechanical engineering to digital health.
But
true. Actually, the reason was that I did a summer school where we sort of developed an application for patients, and then I thought, this is really interesting. And that sort of triggered me to do the switch. And then I started working first for a startup, which then got acquired by PatchAI. For now, I really enjoy it because I just wanted to experience something outside of the research arena.
Yeah. All right, so welcome Ingmar Van Hengel. I really enjoy having you on our podcast. Thank you so much for giving us your time. The things we're going to talk about today is going to be very, very interesting. But firstly, before we start, I just want to know, how did you choose to study and work in the chemistry and polymer science field in the first place?
Yeah, thanks a lot for the invitation. And to answer your question, I actually sort of rolled into it because I first studied biomedical sciences, so that you could basically see as sort of learning similar things as a doctor, but in the end not apply them on patients, so not treating patients, but doing research to find out the mechanism behind certain diseases. And it was actually during that time when I was doing my master's that I got interested also in business. So there was a course called research-based business, and then we sort of looked into developments which were interesting at the moment, and one of them was 3D printing. And so we sort of combined that with our background in biomedical sciences, where you could apply 3D printing to build tissue. In the end, to for instance, make organs using a 3D printer, and that is called 3D bioprinting. And that's basically how I got involved in the chemical and polymer field, because we decided to use this technique for printing of skin tissue. And that's basically how in the end I ended up in the chemical and polymer field.
Yeah, now you mentioned now the skin printing and bioprinting and tissue engineering, all that very, very key words that I find always triggers my excitement for this field of polymer science. But how did you were working on wound healing treatments, and then you actually founded your own startup company, which you called SkinPrint, correct? How did that come about? And can you tell me a bit more about the company itself as well?
Yeah, definitely. This is already a couple of years ago, because it was during my first master degree, where we just happened to do an evening course on research-based business. So it was for life science students who were interested in not just learning about doing research, but also maybe the idea of starting a company, or at least learn a little bit about that. And it was actually there where we sort of combined our interest in 3D printing and trying to come up with solution to solve the donor shortage for organs, and sort of then things came together. So the initial idea actually was to make 3D bioprinters, start selling 3D bioprinters. But we very quickly realized that was not really our expertise, because we were not engineers.
Yeah.
We were biomedical scientists. So we thought, okay, we actually know more about the product that's being produced. And at the time it was also so new that wasn't really being done. And actually we just thought, okay, let's start simple with a type of organ which doesn't have a very difficult, let's say, 3D structure. And that happens to be skin, because although the skin is a super interesting tissue, if you look at it, it's pretty two-dimensional. I mean, in the end, it's just a couple of layers on top of each other. And we sort of built a business plan around that, and it got received very well. People really said, "Whoa, that's a great idea. I think you should continue with this." And that was actually the idea when we said, "Okay, let's see if we can really start this company." So we worked on it for a little bit longer. We attended some startup competitions. So that was a very exciting time, because we also realized that there was a big need actually for skin tissue. For instance, when you think of burn victims, because they often lack enough skin to basically cover their burn wounds. And also the solution is never fully optimal, because if someone has a burn wound, typically you still see that after surgery. I mean, you see that the skin there is different than on the other parts of the body. So that just aroused a huge interest in our startup, basically. However, at the end of the day, unfortunately, we did not succeed to secure funding, because looking back, we were just very inexperienced, and also at that moment, the environment where we were, it was simply not so easy to get so much funding, because we would need several millions basically to start a lab. So what happened then was that during that time I contacted a professor in Switzerland, in Zurich, who had his own lab, the Tissue Biology Research Unit, and they basically were working already for some time on more or less the similar process. So the idea was to engineer skin tissue for burned children. So they also had a close collaboration with with the Children's Hospital. And that's in the end where sort of I did my research on this topic. So using a 3D bioprinter to print actual skin tissue in the lab, and then also do some preclinical experiments to validate the functionality of this skin tissue.
So, is the SkinPrint now that company, is it still continuing, or is it taken over by someone, or how is that going?
Yeah, so the initial company, as we had it in mind, in the end didn't really take off because we were not able to secure funding.
Yes, the funding was good.
Yeah, that might also have been due, like I said, at that moment where we were in the Netherlands, there wasn't really this startup culture. So it was difficult to get funding anyway, and then we were also very young, so maybe that also played a role. So at the end of the day, we said, okay, unfortunately, this is not a real company with which we can continue.
Not a viable option.
Yeah, but so it was interesting because actually we learned a lot during that time. It was super interesting.
Yeah, and I think that the research that you, and I think that the research that you brought into the whole strategy of starting that company and collaborating with hospitals, that's still, that's great ideas that can be taken by other companies or just initiatives that can be utilized for future reference. It's really good.
Yeah, definitely. And if I just may add one thing, because you asked about the company. So in the end, I moved to Switzerland for a couple of months to do research there, and that's also what in the end laid the foundation for the research that we recently published. But there they sort of had all the facilities to actually make this skin engineering come true. So in the end, they actually started a company a couple of years later, which is called Cutis. It's still based in Switzerland, and I think they're doing very well. So they even won a startup competition in Switzerland and are now doing phase 2 clinical trials.
Wow!
So it's really
wonderful.
It's really moving forward. So I'm quite positive that maybe in a few years this will actually be. It will actually be possible to use this technique in clinical practice and not just in Switzerland but also in other countries.
Yeah, it would be so great. I mean, just one more question regarding the SkinPrint. What polymers did you use during that research?
Well, actually, at the end it was pretty simple because we used natural components, natural polymers. Because what we tried to do is we tried to mimic the skin as good as possible in the lab. And basically the first step is to simply use what is also present in our skin, which is mainly collagen. And it turns out that you can actually do that. So how we used that in our bioprinting process was that we sort of had a piston which had like two reservoirs, let's say, and one reservoir was filled with the cells that make up the skin. So you have, let's say, the skin cells. Then we also started to add pigment, so we also added the melanocytes. And the neutralization buffer. And then in the other reservoir there would be collagen. And then if you would mix them, that would make the collagen solidify. So you would get an actual hydrogel. However, if you just put that together, then you end up with something that's, in our case, was about a centimeter thick. But it was very unstable. I mean, it would just fall apart if you would touch it. And that's where the second step of the process comes into play, which is called plastic compression. So basically, it's simply pushing a squared stone, if you will, onto this printed construct, which contains a lot of water, actually. So what we do is by pressing onto this construct, we press out the water, and we end up with something that's about 1 millimeter thick, and it's much stronger. So it's something that you can actually lift. So it would also mean that the surgeon could lift it and transplant it onto the patient. So that's a pretty crucial step, because without this step, you would just have something which is not mechanically stable and not useful at all. But simply by, in the end, squeezing out the water, you end up with something that's much stronger. And it's also a nice approach because you don't add any chemicals or something which might disturb the regeneration process.
Yes, yeah, that sounds wonderful because it's like you said, it's more biocompatible, and even like getting that moisture out, I think will be beneficial because you don't want to introduce or have the option of bacterial growth and things like that on the wound. And I think excess moisture on a burned wound is not that great as far as my knowledge goes.
No, you're definitely right, and it's definitely important to prevent infections, and that's also not only after transplantation, but also when you're growing these tissue engineered constructs in the lab. It's very important to work in a sterile environment. And the thing is that the bigger these pieces get, the more difficult this becomes. I mean, it's just more likely that somehow bacteria or fungus will drop in and start an infection. And actually in the lab there in Zurich, they had developed a very nice culture construct. You can also find it in the publication, where we were able to add different types of medium. So you can see that as nutrition for the cells. Because in the end, we would print 2 layers of skin. So you have the top layer, which is the epidermis, which is the layer that you see. That contains the pigment and secures the barrier function. And then below that you have the dermis, which has the blood supply, the innervation with the nerves, and basically gives the stability to the skin. But the challenge is of growing such a construct in vitro, so in the lab, is that you have different types of cells, and they, so to say, they like different types of food. And so they made a construct which allowed it to, on the one hand, on the top of the construct add medium type A, and at the bottom add medium type B. And because of that, both parts of the skin tissue, let's say, were happy and were growing very well. So
yeah, just in terms of the wound healing treatments that you are doing, or that you did with the SkinPrint, how does that compare to common approaches with wound healing treatments that were most classically used?
Yeah, I think the main difference is the end result. So if you look at other products which try to aim at the same thing, so reconstructing the patient's skin, the difference is simply that we really reconstruct the skin of the patient. So the process actually starts with taking a small biopsy, from which we then isolate the different type of skin cells, which we then put together with 3D printing, and then we grow the skin back in the lab, and we transplant it back onto the patient. The thing is that this takes time. So this takes, depending a little bit whether you want to include blood and lymphatic vessels as well, for instance, it takes between 3 and 5 weeks. So that still means that, okay, let's say you would have a burn victim, you would have to use temporarily wound dressings, which they also use now in the clinic, to cover this first 3 weeks. But then after that, you would basically transplant the skin back onto the patient. And we see from the first clinical trial results that, the end result in the end is much better. And that is simply because we transplant the entire skin. So not just the top layer, but also the layer below. And what is done currently is that they sort of scrape off a piece of healthy skin from a part of the body of the patient that's not burned.
Like grafting it from...
Yeah, exactly. So it's an autograft. So you can imagine that's already not so pleasant, but it also means that you only transplant the top layer of the skin. And when you do that, it means that you will eventually cover the burn wound, but because you lack the underlying layer, this skin will in the end become scar tissue. And that means it's simply not elastic, which is not just, aesthetically it doesn't look good, but it also might impair movement of the patient. So let's say you would be burned around your elbow. Often with this autografted skin, you would see that patients would have difficulties moving their elbow simply because the skin is too stiff. And when you think about burnt children, there's another problem because the skin doesn't grow along with the patient. So because children grow, they literally grow out of their own skin, and so it means that they would have to go back to surgery every few years because they sort of grow out of their skin tissue. So the idea is by sort of giving back the actual skin to the patient, like the complete skin, if you will. Hopefully that would really take, and this skin would regenerate by itself, and hopefully you can reduce the number of surgeries in the future. I mean, this is something that we hypothesize and that will have to be shown in clinical trials. But like I said, the first results are quite promising. So
okay, sure. Just to move on to the next part of your studies and research, you have moved your focus a bit more to 3D printing implants and digital health. So can you tell me a little bit more about that, and what is the meaning of digital health, and what does it do, and how does it work?
Yeah, indeed, definitely. So actually, when I was working on SkinPrint, that really triggered my interest in the use of technology to solve medical problems, and more specifically to use 3D printing to make things which in the end help patients. So, of course, skin printing was a great example. But then I realized I needed more knowledge on the technology, and so I actually moved to a technical university where I did another master in biomedical engineering. And then my graduation project there was to make 3D printed implants, orthopedic implants, so in this case made of titanium, which could, for instance, replace a hip joint or knee joint, so very frequently used. And the idea was to make implants which had sort of a surface treatment which caused them to prevent infections. And actually that was such an interesting project that I decided to make my PhD out of that. Luckily my supervisors managed to secure some funding, and then I did my PhD basically on 3D printed implants which were designed to prevent infections.
I would actually like to hear more about that, about your PhD study, especially about the implants and so on, and how that worked with preventing the infections and so on. Can you tell me a bit more about your PhD while we're on the topic?
Yeah, definitely. So maybe to start off with the implants itself. So I guess that almost everyone nowadays knows someone who received a hip or knee implant. So they're very frequently used, and I mean it's a great medical invention because it gives people back their mobility. So it's really incredible. I mean, people just have a lot of pain, sometimes can walk normally again within just a couple of weeks. It's really amazing if you think about it. However, of course, everything can be improved, and the thing is that because we have an aging population, so people luckily get older and older, we see that patients start to outlive their implants. So typically a hip or knee implant is designed to last, let's say, 25 years, and that used to be enough because people would simply not frequently get over, let's say, 90. But now that that's more and more the case, we would actually like to give patients something with which we know for sure that they will last a lifetime. So to do that, you need to sort of optimize the implant from a mechanical standpoint, because it's been shown that if you design the implant in a certain way, you will actually stimulate the surrounding bone tissue to regenerate and that will improve the longevity of the implant. And that's where 3D printing comes into play, because 3D printing allows us to basically create any design that we come up with. So we can basically look at the anatomy of the patient, do some mechanical analysis, and come up with sort of the ideal implant, and then actually print that implant. So that's a small part of it, and then I was focused mainly on complications that arise after implanting such a hip or a knee implant. Although the majority works very well, sometimes patients unfortunately develop infections. And though that's a very small percentage, because the number of people that receive such an implant is so big, in the end also quite a large number of patients in the end develop infections. And when left untreated, this can have severe side effects. I mean, patients can lose their mobility again, or really the worst outcome is systemic infection, which might cause a lot of problems. So to prevent that, the idea is actually to add something to the implant surface, which sort of, especially in the initial stage after implantation, basically kills any bacteria that tries to approach the surface of these implants. So we had a surface treatment that we developed, where we applied, for instance, silver nanoparticles onto the surface of these 3D printed implants, and thereby create so-called self-defending implants, which would then prevent infection. And we have tested these implants in preclinical models, where we sort of mimicked infection that would also occur in patients, and the results were quite promising. Hopefully this will be continued further, and once again, in a couple of years, we can really have implants that would reduce the number of infections. I don't think we'll be able to completely eradicate all infections, but at least significantly reduce the number, and so that patients can really enjoy these implants for their entire life, basically.
No, that's true. Like, as long as you can just minimize that risk, and like, obviously the bacteria and all that always develops and evolves and tries to become some sort of superbug at the end. But I mean, if you can minimize the risks and minimize the infections, like, that's wonderful.
Because you mentioned resistance, that's actually one of the reasons why we started this research, is because unfortunately a lot of the bacteria that cause these infections are becoming resistant to antibiotics. MRSA is one of the main pathogens that is involved in these infections, and so it becomes more difficult to treat these infections, and that's why we started to use other tools like silver nanoparticles. But it's always a balance, because in the end bacteria tend to become resistant to whatever you give them. So it's always just a matter of time before we have to invent something new.
Yeah, no, that's very, very true. Like, the constant development of technology is always a requirement. We can't be stagnant. You have to, like, that's why research is so important, and the continuous building on each other's research and sharing the information. And yeah, that's very, very cool. So just my one question for digital health. Can you tell me a bit more about the digital health and how it works? And just go a little bit more in depth about that concept, because it's very unfamiliar to me. I've not heard of the word digital health before.
Interesting question, because really digital health can mean so many things nowadays. Maybe I can explain it best by explaining in the end how I ended up in digital health, because I did pretty different things, and might not be a logical step from, let's say, biomechanics to digital health. Because it was actually during my PhD that I did a summer school, which took place in a clinic just outside Berlin, where we were asked to develop a prototype of a platform where patients and doctors could interact, and they could talk with each other, they could share certain files. And that was really interesting, because actually the first 3 days we spent on investigating how the procedures worked in that hospital. We were working mainly for the psychiatric department, and we really went from attending patient interviews, talking with physicians, to in the end really developing something that had an immediate impact on patients. Because even though it was just 2 weeks, so we just developed a very rough prototype, the people there, they were so excited because they said, this is something that we've been waiting for years. We've been using all kinds of software solutions, but they're just way too complex and they don't give us what we need, and you just gave us that. And that made such a huge impact on me that I thought, whoa, this is really amazing, because you can actually do something which immediately helps patients. So that triggered my interest in digital health. And then when I finished my PhD, I was interested to work for a startup. And in the end, I was fortunate enough to actually find a startup which worked on sort of a similar thing, was called PatchAI. So they developed applications for patients that participate either in clinical trials or in standard care programs. And so it gives patients a little bit more control, let's say, and also insight into their treatment. And then at the end, this startup was acquired last year by Alira Health, which is let's say, full spectrum service provider for startups and bigger companies throughout their life cycle drug development. So that's what I'm currently working on getting more and more of these digital health applications to patients.
Because I was thinking about people like my father, maybe that has like a handful of pills to take every day, and how you can just get confused and forget, because if you're the person that needs to take the pills, obviously you yourself aren't well, so you won't remember to take them, or how many or which ones, and so on and so on. So is that like also how the digital health can be useful, right? Like how you can make that work for you as a patient, as a person.
Absolutely. Yeah, that's one of the things that will also in the end help the development of new therapies as well. Because right now we don't really have an insight into whether patients really strictly adhere to their treatment schedules. Because if you don't know if a patient is taking medication, then how can you judge whether that medication actually has an effect on their condition? And that is something that we'll see more and more. And another interesting development, sort of tying into this, is called real-world evidence. So it simply means that you follow people that are, maybe follow is not the right word, you give people the opportunity to participate in such a program where they are on a certain, using a certain treatment. You ask them simply for feedback, and you can combine that with a wearable, like a smartwatch, for instance, if it might be beneficial to measure things like blood pressure, oxygenation of the blood, or whatever. And then you can combine that data to actually, in the end, come up with a better treatment plan for individual patients.
That's
great. We're still not there yet. That's still, I think, a pretty long way to go. No, but
I think it's a necessary progression into the future, because with all the variables and the different type of people and genetics that comes into play, you can't really these days say, taking that pill will give you this results, or taking that pill will give you this side effects, because there's so many different types of people, different types of ailments and underlying, things that can, give you false impressions and false data. So that's really, really important to keep growing in that direction with this technology.
Because actually the interesting thing is that the challenge is nowadays maybe not so much into collecting these data.
Oh, yes.
I mean, that's possible, but sort of getting data that is of, let's say, high enough quality to actually be useful, because there's usually a lot of noise, or you're not exactly able to measure what you would like to measure, so you deduct it from a variable that you can measure. And these kind of things really pose huge challenges when it comes to the usability of this data, and it's something that you need to think about beforehand, Because if you don't sort of design your data collection well, you will end up with data that in the end doesn't allow you to answer your research question.
Oh, yeah.
That is basically in a nutshell the big challenge of digital health nowadays.
Yeah, that's a great summarization of it, yeah, for sure. Awesome. Well, is there anything else that we should know about digital health if we want to, learn more about it or go find out more about it ourselves? Where should we go and look?
Well, you can, of course, start maybe take a look on the website of Alira Health. There you will find some of the in-house application that we are currently developing. The thing is that digital health, it really means going from, let's say, analyzing MRI data to making applications for patients to help them manage their condition. Then the next thing is digital therapeutics. So it's actually that the digital component is the treatment itself, or at least a large part of the treatment. That will be something very interesting, especially for mental health. And that is something that we just are seeing starting to emerge. So there are definitely so many components of digital health that it's almost impossible to say in one word what will be the main development. It will just become a bigger and bigger component of healthcare in general.
And it is a volunteering type of system. So patients have to be able to volunteer their data to, develop this digital health system. But so there's no risk of being, exposed or, getting your data leaked or anything like that, because I'm certain that security will grow as well as technology grows, obviously.
Indeed. So in order for digital health to work, you would need to have trust and also transparency. I think if you lack both, then in the end, patients will just not use your application.
That's true.
And that's something that digital health developers owe to their end users, in this case patients or physicians as well. So that's something that we as a digital health community definitely need to work on. And I think it starts with transparency, because if you're not transparent and the patient doesn't understand what you're doing with this data and how it's being processed, then you will never be able to gain the trust of the patient. So there's also a huge challenge when it comes to digital health literacy, making people really understand how digital health solutions might benefit their condition. And these things take time and need to be done well. So.
Yeah, it needs to be done properly so people will not lose trust in the system as well. Yeah, that's true. A very good way of ending the podcast. But I just wanted to, before we end, just ask, is there any future plans, any hopes for your research that you're building on, or that you hope for your development in the future?
So like I already mentioned, I'm quite positive about the future of skin engineering. I think it will really be one of the first tissues that we'll be able to actually manufacture in the lab and use in transplantation. So I'm quite positive about that. When it comes to 3D printed implants, I'm also quite positive about that. There are some challenges when it comes to the manufacturing process, because unfortunately 3D printing is still relatively slow, and because there's such a huge volume of implants needed, I think we still need a fabrication method which sort of combines the two. So it allows for the free-form fabrication of 3D printing, but at the same time also has the speed of conventional techniques. And when we will be able to overcome these challenges, then we really can start thinking about making customized implants the standard of care. And then hopefully also combine that with the surface treatment method that we use to sort of reduce the number of infections.
Wonderful. Well, thank you so much for your time. I really appreciate it. you sent me some links for SkinPrint and your publications and so on. So I'll post that all on the show notes of this episode, so people can go and check that out. And thank you very much for your time. I really appreciate it, and talking to me about your work and all the interesting stuff about tissue engineering and bioprinting. I'm sure the listeners will enjoy that as well.